All right, guys. Thank you all for joining my session. From Monolith to K8s. I wanted to ask who joined my session last year. Can you guys raise your hand? So, okay, we have some people. That's good. I will be expanding on the topics that I discussed last year. My presentation is on YouTube. If you want to see my last year presentation. I will mention some of the tools that I mentioned last year as well, and go over some of these tools in more detail, because last year was like full of things, and I wanted to spend more time on some tools that I've been using also during this last year, and they are super useful, and they will help you towards this journey. You can ask questions in Slido. You can just join there and ask questions while I'm talking, and I will try to cover some of those questions at the end of the session. So, quick raise of hands, who is using Kubernetes? Whoa, that's definitely more than last year. So hopefully, to some people, this will make some sense. For the ones that are not using Kubernetes, well, these are kind of like the challenges that you will face while going from being a Java developer or Scala or any other language to deploying something into Kubernetes. And again, the main scope of the presentation is to show some tools in action. My name is M.Salatino. I'm also known as Salaboy in Twitter and GitHub. I have my blog there, and I do work for a company that is called Camunda, and we do microservices orchestration for the cloud. That's CVHQ. If you wanted to know a little bit more about that topic, please follow those Twitter accounts. And I'm also helping the Learn K8 guys, which provides Kubernetes trainings. So if you're interested in these topics, please get in touch and follow these accounts or just drop me a message or whatever. So, in order to start with this presentation, I need to do this. Okay, things will not work, right? All the presentation is mostly working against a remote Kubernetes cluster that is running on Google. So, what can possibly go wrong, right? Like the conference Wi-Fi, it's live. I'm running at least 50 containers are being started and destroyed. So it is going to get complicated, and the stack is quite complicated per se, right? Like GKE in Google is one thing, then you have Knative, you have all this kind of like serverless stuff going on. So we will see how it goes. If it breaks, please bear with me. I will try to explain how to solve some of these problems if they appear. If the connection goes down, there is not much that I can do. So I will just try move forward with the conceptual side. And of course, as usual, this is kind of like something that I put always in my presentation, monolith first. That's why the presentation is called From Monolith to K8s. If you have like a monolith right nowadays, if you're using Spring Boot or any other technology, you can always pack up your monolith, put it in Kubernetes, so you put it inside a Docker container, and you just run it. That's kind of like the first approach. And then if you understand how that monolith works, then you can start splitting it up in microservices. Just creating something like microservices without understanding how the application will work, it's quite risky. And there is a very interesting article about that it's called Monolith First. If you Google it, I totally recommend that. So let's start with the monolith, right? This year I will just use this concept, this scenario of a conference site. Imagine that you need to host a conference like GeeCON, and then you create a simple application, simple web application that will have different modules to do different things. A back office, a public-facing website, attendees, tickets, agenda, call for proposals, sponsors, and all these things, right? The more that you put in there, the more complicated it will get, and all these modules will be very difficult to split up if you want to do that. You can argue that a conference site should be small enough, to be handled in a monolith, and that should be okay. But the whole point of the example is to show something that we can all understand, and that you can apply to, to your real-life scenarios. So when I discuss this, don't think about the example per se. Think about in your own situation, if you want to, target Kubernetes for scaling, how you can apply these concepts. First part, Jenkins X. I mentioned this last year, and I will mention it again, and I will show it in action again, because I think that this is one of the fundamental tools that helped me to build a very high-performant team. We were 4 guys dealing with 100 repositories, and we dealt from creating the source code, creating the services, to deploying that into Kubernetes environments. And that was only possible because we were using this and because we invested into that community. So instead of describing what Jenkins X is, I just wanted to show it working. And this is where things will probably go wrong. As I mentioned before, I'm running this into Google Cloud, but I wanted to show you a quick application here. Spring Boot run. So I'm just starting a project that I have in GitHub that it's called Demo Conference Monolith. It's a Spring Boot application. I'm just running it here locally so we can all see it. That's pretty much it. So normal conference kind of thing, call for proposals, where you can just create a new proposal, and then a back office where the organization can approve or reject the proposals, and then notify via email if you were rejected or accepted, and then some agenda section where we can see which talks are going to be presented there. We should have something or a connection to an email server or something like that. And because we have a monolith, of course, this will have a unified version. Every time that we want to change any of these sections, we will need to change the application source code, we will need to build it again, we will need to release it. So we have a single point for releasing in there. And what I wanted to show you here, I will just kill that application. I just wanted to show that even if you have a monolith, you can start with Jenkins-X in order to have CI/CD. If you want to run that application into Kubernetes, well, as I mentioned before, you need to wrap it in a Docker container, write some YAML files, share the Docker container into a registry so the cluster can get it, and then just deploy it to that cluster. And that usually, if you are a developer, you can do that. As soon as you do it 3-4 times, then you start saying, well, this should be automated. I don't want to write any more YAML. I just want to tune things whenever I need it. So Jenkins-X gives you that kind of thing in general. And the first thing that I will do, I can show you the source code repository for that application, just a Spring Boot application, nothing else, right? POM file, nothing weird in there. So the first thing that I will do from that application directory is JX import. And I will explain a little bit about that, like how Jenkins-X works. So I'm running that. Again, this is going to the cluster. So if it takes time to go and create it and do the requests, well, this is going to take a little bit more time. The only thing that this is doing is telling Jenkins-X, hey, here I have a project. I want to do all the things that I want to do in order to have it running in a Kubernetes cluster. So that's creating and registering the project into Jenkins-X. And Jenkins-X is split into 2 big parts. One is the command line, and the other thing is the backend server-side thing that is running the pipelines, right? So while this is running, what I can do is I can try to see the logs from that pipeline that is running. Oh, it's not there yet. So I will explain a little bit more about what's going on in the background. So I just registered the project. This is what I want. As a developer, I have a service. I have some source code somewhere in Git. I want to put it in a service running in Kubernetes. It could be a service, it could be an application. So that's what I want as a developer. How Jenkins-X solves this problem and try to help us to get that done is by allowing us with the command line tool to say, okay, I have a new project. So it will register a watch to that Git repository. It will create some hooks to be notified every time that the source code changes. It will be automatically create a pipeline. And at the end of the pipeline, something interesting is going to happen. The pipeline will release the artifacts, but instead of pushing those artifacts into a namespace or into a service in Kubernetes, it's going to create a pull request into another repository. And Jenkins-X is using this idea of GitOps, the idea of having your cluster state into a Git repository, and then having components to sync that state from the Git repository to the cluster. So at the end of the day, you just send a pull request to a specific Git repository that is going to evaluate the pull request with some pipelines. And then if everything is okay, it's going to merge that into master, and then the state is going to be reflected in a Kubernetes namespace. That basically means your application will run inside that cluster, inside that environment specifically. By default, Jenkins-X provides 2 out-of-the-box environments, which is staging and production. And when you run a pipeline, as I just did, imported my project in there, it will automatically be promoted to the staging environment. That means that at least I can see it running somewhere. And if everything is okay, then I can manually promote to production, right? That's a separate environment. Jenkins-X also allows you to create custom environments. Let's say that you want to have a QA environment where you run more tests that you run in staging, right? You can quickly add a new environment in there and use the same practices. Also, you can also send pull requests to that environment from outside Jenkins, right? It's Jenkins-X. So you can just go and create a pull request saying, okay, I have a new version of this service, or I want to add more things into that environment. Then you just send a pull request to there. The pipelines will take care. The pipelines are doing a bunch of stuff, right? Are doing a very interesting stuff, and they are very opinionated, right? These are the kind of things that when you go to Kubernetes, it's better to get the best practices from the community instead of you trying to define how to do every little step. And these pipelines are basically relying on these community best practices. So as I mentioned before, when I did JX import, the first thing is a webhook. The second thing that I didn't mention is that as soon as you import the project, Jenkins-X will try to understand what's inside that repository. In this case, it was a Maven project. So it recognizes that, and then it decorates my project with some other files, like, for example, the Docker file and all the YAML files that I need in order to deploy my service or that container into Kubernetes. And that's done using the concept of build packs. So you scan the content, say, OK, this is a POM XML. That means that the Docker file should look like this. And this means that the YAML files should look like this. And they do that by templating. Of course, they generate like the initial version. You can change them after, right? If you want a different Docker base layer, you can just go and change it. And then at the next step, it really instantiates a pipeline in the backend service. And that pipeline will do the things that you would expect to do, like in the Jenkins pipeline, like clone the source code, build it, and test it. But then it's going to do a release. So it uses that idea of every change in master, I will generate a new release for you. And the whole point of doing that is that to start getting out stuff quickly. Right? One change in master, it means a release, and you kind of like need to get used to it. Most of companies out there, they are not doing that. It's kind of like a big change, but when you start doing it, you realize of all the advantages that you have with that. And then, of course, it builds the container. It pushes it to the Docker registry. In this case, because I'm running in Google, that's JCR, which is the Google Container Registry for Docker images. And then at the end, it pushes the Helm package, the Helm chart to a chart repository as well. But the most interesting part is the last pull request there in the chain, right? At that end, basically sending a pull request to the environment, and then the environment will have a pipeline to evaluate that change, verify that the change is correct, that the new service can be added to that environment. If that's OK, it will merge the changes, and it will apply that to the cluster. So let's see now if I can take a look at the change at the build steps. And again, this is where the connection might go wrong, but the pipeline finished, I think. So I can check my application. It's not there. So basically, again, as I mentioned in that slide, the pipeline will run once for building the project. Then the environment pipeline will run to verify the pull request. As you can see, that's the pipeline for the project. That's the pipeline to verify the pull request. And that's the pipeline from master for applying the changes into the cluster. So I can take a look at the logs. At some point, this pipeline will finish. It did finish. And it says that I'm applying all the changes that I need to apply. And I can do something might fail. Well, no, it's there. So we can see I have a new project there that it's called Demo Conference Monolith, and it's starting up, right? So 33 seconds. And I need to explain that as well. So these pipelines, the first time that you run them, of course, they will take time. They need to download all the Docker things, all the Docker layers into the server, build the application, move files around, do a lot of stuff, running the pull request verifications and all these things. And by default, the memory allocation for a Spring Boot application, it's quite low, so it takes kind of like around 50 seconds to get started. At some point, it will start. Now it's done, like, yeah, less than 60 seconds. So now I should be able to do get applications, and I should be able to access my application. Right, so that's my application. And voila, we have the application running in the cloud, right? So for me, when I saw that at the beginning, I said, well, this is good. This might help us, right? And by checking with different people, they all said, OK, this will work as soon as you have services or Spring Boot applications, but if you have libraries, that's different. Can you do that? Yes, you can. I will not show how to build a library here, but the process is pretty much the same. You just add a library, they will recognize that it's a library, and then you just run the pipeline. At the end of the pipeline, you're going to get a jar into a Maven repository. Same thing, you can change repositories, so you can change projects and say, my monolith depends on that library, so build the library first, and when that library has a new version, please include that new version into the application. I have some examples about that. If you're interested in that, please let me know. So let's move forward. Feel free to ask questions in Slido, right? So that's kind of like what Jenkins X does, like super high-level overview. What happens when you start splitting stuff into microservices? Then you face a different bunch of other problems, right? Last year, I mentioned a couple of projects. I mentioned JHipster, and I mentioned Spring Cloud. And again, this year, I will not mention JHipster, but it pretty much like the architecture when you generate a microservice application with JHipster, and tomorrow we have a presentation about that. It kind of looks like this. So you always have like a main entry point for your application. And that in itself, it poses some challenges, right? So now I will split the application into the front end, the conference site, the call for proposals, the agenda, and the notification services, right? The first thing, and the first problem that you might envision is now I have 4 repositories to deal with. That increases the complexity by 4 or by X. And that's basically, again, what Jenkins X is trying to solve. It doesn't really matter how many repositories you have. They all follow the same approach. You just import them, and they are just running in Kubernetes. So one thing, again, as you might notice, is like you have now one single entry point. The last thing that you want to do is you want to create a front-end UI that is talking to tons of different services, right? If you do that, then you need to expose all the services to be accessible from outside the cluster. In this case, what I've done is I went and created a conference site to be like a router. So every time that it gets a request for one of the other services that are down there, I will just redirect that request, and I will route the request through the conference site service to the downstream services. So I did that by using Spring Cloud Gateway. Spring Cloud Gateway, it was before, some time ago, it was based on Zool. Nowadays, it's completely rewritten using the reactive stack. And it is super powerful, right? And again, here I'm just showing a super simple example. I had my conference site Spring Boot application. I just added a dependency. That's the Spring Cloud started gateway. And now I have a router for requests, right? The next thing that I did, I realized, okay, from the front end, I will be sending requests to the call for proposals service. So I just created this route here, and that's all I needed to say, if you are calling to the conference site /C4P, I will redirect that, I will just redirect those requests to the backend service that it's called like that. And that name here, demo conference C4P, it's a service that it's running inside the cluster. It's not exposed to the outside world. So I don't want my UIs interacting with that service, right? In this way, I'm just rewriting the request, arriving conference site, and I'm routing them towards that specific service. That service is going to deal with it. That's super cool, super fast to do. So what I did is in my GitHub account, somewhere here, I have 4 services, as I mentioned before. I have the conference site, conference email, conference C4P, and conference agenda, as well as my monolith that I just imported. And what I did with this, I just created 4 Spring Boot applications, and then I just did the same thing that I did before. I don't want to import them here because it will take that time to import the projects, but I did JX import into each of these projects. One thing that I didn't show for the monolith, and sorry to go back, but I wanted to show that idea of every time that I change something in master, in this case, when I import the project, I created a release. Right? So as soon as I imported the project, I got the release for it. So I have a new version of it. I have a publicly released version of that artifact. And I will have a jar with that version, I will have a Docker image with that version, and I will have a Helm chart with that version as well. How many of you guys know Helm? Some people does. Well, Helm, imagine like the Maven for YAML files, basically. But you will need it. If you are using Kubernetes in real life, then you will need that kind of stuff, as we all know. So again, for the 4 projects, I just did JX import. That means that now I have 4 other services running here, right? So agenda, C4P, email, and site, that is here. And as I mentioned before, the site is the main entry point. So if we want to take a look at that application, I have it here, right? First thing that you will notice, now each block, I'm not using micro frontends or anything, it's just a single frontend, but each of these blocks is talking against a different service. So each of these blocks have different versions, right? So we have the site, it's version 36, call for proposals version 35, and agenda version 22, and email server version 009. This basically allows us, in my real life project, allows us to evolve each service independently. So if we have different teams working on different pieces, we can just evolve them independently and move forward. You can deploy them individually now. Then you can say, okay, I just want to make change in the agenda service. I can just deploy a new version. If everything, like if the APIs is still the same, all the services should be able to keep contacting them. So you need to start thinking about backwards compatibility and all these things that in real life make sense. So when you start migrating to this kind of approach, you start thinking a lot about, okay, use cases, right? So it doesn't make too much sense just to split things because you want to split them. You need to split them and test that you are still, achieving like what the application is supposed to do, right? So in this case, I was trying to implement this flow, which is you send a new proposal to the conference. There is a potential speaker that goes to the conference site, fills a form. That proposal gets received in the call for proposals service, and basically this flow happens. So on board, the organizers, the people organizing the conference needs to review and approve or reject the presentation. If it's approved, I need to create a new agenda item, basically just post that into the public agenda, and then notify the speaker if it was rejected or if it was approved, right? I was trying to implement this. And basically, that's this example that I have here in the UI. I can create a GeeCON. Yep, that's me. Please accept, for example. I will send that request, and that request will appear there. And now I have the option of accept or reject. In this case, right, that's kind of like should be in the back office. I'm a super lazy front-end developer, so I just put everything in the same screen without changing or setting users or security. So bear with me. So if I accept that, right, I should be able to see that presentation here in the agenda, right? Simple use case, super simple flow. Of course, this is kind of like hello world kind of thing. In reality, this is not going to be like that. That makes me go to the IDE to show you a little bit about that code, which is super simple, and I guess that you all kind of like understand this because it's super basic. So basically what I'm doing here, this is the call for proposal service, the main application. I didn't even split that into two classes, but bear with me. So new proposal, I'm just getting a new proposal and adding that to my in-memory database, AKA hash map, I guess. Hash set, yeah. So super easy, that's there. If it blows, so if I kill my pod, that will go away. Room for improvements there. So that's receiving a new one. If the next step, as I mentioned in the flow, is for someone to make a decision based on that, so you can just go and see all the the proposals that are there, and take a look at what are the ones that are pending to be accepted or rejected, and then you call this other endpoint, which is basically sending a decision. So this source code here, it doesn't do much. It basically gets the proposal, changed based on the decision, the approved flag, and then it changed the status of that. In this case, decided. That means that that's done. I don't need to do anything more about that. Then we start having like this logic, the logic to implement the flow, right? What happens after somebody make that decision? If it was approved, I need to send it to the agenda, and no matter what, I need to send an email to the speaker, right? Like the one that proposed the presentation. And if you take a look at these two methods, basically it's just sending a REST request to each of these services. That basically means that here I have like an explicit definition of which services I depend on, right? And that's kind of like okay, because now you know which services are going to be called by this service, and if you need to change the APIs of those services, you kind of know where these changes are. So in general, for an example, this is okay, right? But in real life, we need to have some considerations. And those considerations tend to be around dependencies, right? So how do we define our service dependencies? Where do we keep them? How do we change the flow? If we want to change the flow, how do we change it quickly in a way that people can understand what's going on, right? I'm pretty sure that if you show this to anyone, they will kind of understand what's going on with proposals and where proposals are going and which services are, required in order to fulfill this order. The flow in our scenario, it's buried there in the code, in the source code of the application. So only a developer will understand what's going on. When you start having more real-life features that you need to implement, like time-based constraints on, I need to be reminded like 2 days after a proposal was posted, so I need to make a decision on that. And if I don't do that, I will keep getting notifications about that. If you want to implement that, of course you can, but there is something new now that you need to take into account. You will probably have some kind of like timers. And then if you're running in Kubernetes, you kind of like need to make that highly available in order to make sure that if the timer thing goes down, when it goes up again, you can just trigger those timers again. Edge cases and unhappy paths, that's where it tends to get messy, right? You start adding more code to deal with exceptional things that might happen. Let's say a service was down, you try to make a request, it failed, so you approved the thing, created something in the agenda, but you never notify the speaker, and then you are like in a mess. How do you check those? How do you build like that resilience in there? And there are frameworks and there are services in the infrastructure that can help you with that, but it tends to get messy, right? The more that you deal with that in code, it gets more and more complicated. And then the last part that I think that it's key for this kind of scenarios is like, data, right, and data models. In this case, if you start to, start creating all the code for answering the most common questions that you will have for this use case, then you will realize that there is a lot of things that you need to do, right? How do you answer questions about how many, proposals were created this week? How many proposals are still, open for review in the last 2 hours, for example, that kind of stuff. It requires you to create a new data model to be able to answer these questions in an efficient way. So for this example, again, it might sound simple. For more realistic examples, it might get complicated. If you add reporting and analytics on top of that, then it becomes way much more complicated. Then you start adding more stuff into the infrastructure, like Elasticsearch is a common use case, right? You start sending data to Elasticsearch. You have a different model there in Elasticsearch to be able to answer these questions. One possible solution for this, and again, this is just one possible solution. There are tons of other solutions to these kind of problems, is doing orchestration. And that's why I wanted to quickly introduce a project that I'm very close working with, that it's called Zivi. It's microservices orchestration. And it's based for scenarios where you really need low latency and high throughput. So again, this case doesn't make much sense, but you can use it for this as well, right? If you want to if you want to scale, if you want to have a scenario where you are creating tons of these flows per second, well, this framework might help you. If you want to know what's going on in the project, again, if you can follow that Twitter account, that will be great. And take a look at the website as well, because there you can find more information about how this is architected and how we are achieving that high scale. So if we want to use orchestration, then we will end up having something like this. The call for proposal service will define what's the orchestration that we need, which is basically defining that graph, that it's pretty much what we were doing in code. We receive a new proposal, then we wait for a decision to be made, then based on that decision, then we choose to say, okay, let's send the rejection email or publish it to the agenda, or publish it to the agenda and send an email saying, okay, you were accepted. If we wanted to keep this orchestration mechanism, basically we'll keep all the data about what's going on. So you can go to Elasticsearch in this case and just get that data that's optimized for answering questions about that. And again, if you have these timer-based constraints, you can quickly add and change this diagram to say, okay, add reminders, add notifications, whatever you need for your real-life interaction. So before moving on how that works, I wanted to show you how you add that into the environment that I have already running with the services. My services are running without that. I just want to add all of that in there now. So in order to show that, okay, so I have more questions there. Yes, super good. So let me show you a little bit of that. As I mentioned before, in Jenkins X we have environments. And the first thing that I did, and I already have it running there, I can make this big, right? So in my environment, I just added these two dependencies here. These are Helm charts. And again, environments are based on Helm. And again, this is pretty much like Maven. I'm saying to the environment, please, add the orchestrator. In this case, it's kind of like a cluster of nodes to orchestrate and to scale. And then add a UI, a front end to query that data, right? And that's going to give me automatically some insights about what's going on, which orchestrations are running there, and how everything is working. So I can keep track of that and troubleshoot if something goes wrong. The first thing that I will need to do is I will need to definitely change my call for proposal code, right? So this is the class that I showed before. And because now I'm using orchestration, I don't need to keep my orchestration, like my services that I'm going to contact here. I will let the orchestrator to understand what's coming next. So I don't need to contact those services from this service anymore. I just need to define how the flow will go and which services are going to be called at what time. In order to do that, as I showed in the slides, I have this kind of like chart. This is basically a workflow that explains what needs to be done. And now I can create new instances of this, right? So I model this workflow, which basically is saying kind of like the parameters for that message. What do I need to wait to happen and which information is going to come in order to move forward. And then I have kind of like a decision here saying if it was approved, do this. If it was rejected, do that. And then I have the services, right? This is basically published to the agenda, and it only has a type there, and we will see how to create those interactions and what options do we have in there. So the first thing that I did is I commented out the services there. I will comment out these methods because I will not need it anymore. I can delete them, but yeah, bear with me. I moved that diagram. It's an XML. It generates an XML. It's there. That's based on standard that it's defined by the industry, so companies know how to create these diagrams in general. And then basically what I will add here, it's Maven Dependency. If you can see it here, this is just a client, right? This is a client that it's going to interact with the cluster that it's running in my environment, and it's basically going to say, okay, I want to run this orchestration, I need a new instance per proposal, basically. In order to do that, yeah, I will just comment this out as well. In my Spring Boot application, I need to do this, enable CV client, and then I will just copy some things from here because I'm lazy typer. So this is basically saying, okay, this application, in this case, this service is defining a new orchestration workflow. I want to deploy it when this service starts. If I start changing the steps in these flows, every time that I deploy the application with a new version, the cluster will realize there is a new version, and it will always run the latest version unless stated otherwise. When I receive, then I need to add the client so I can interact with the cluster in this case. So there I'm interacting with the cluster, and then when I receive a new proposal, basically I want to say I want to create a new instance of this workflow, right? How do I do that? That's a very simple command that is going to be executed. And again, this is kind of like IntelliJ showing all the intermediate objects, but in general, the things to take away from there is create instance with that name. That's the name of the model, the workflow thing that I have. And then that's the latest version. Again, this is version by default, so you can just change and specify the right version that you want to run. This is the data that you should use, in this case, the proposal that's reaching in, and then just send and join because it's on a sync thing. Again, same change here in the decision. In the decision, I need to notify the orchestration, okay, these people already made a decision, so move forward, and this is the decision basically that I have. So I have that here. And again, the key points to take away from here is I'm sending a message to the orchestration saying the decision was made, this is the proposal ID, so you know exactly which instance to move forward. You can move forward multiple instances depending on your use case. And then just send the proposal that was updated with the state here and the decision that was made, right? So I'm changing that. That's pretty much it. And the last thing that I need to do, because I'm running this in a cluster, I need to basically configure my application to know where the cluster is running inside the Kubernetes cluster, right? So what I have here is just a property, basically says, okay, there is a service in Kubernetes that is called JXCV, in this case, that's there, and it's in that port. So imagine this. This is pretty much what you're going to do if you, let's say you want to add Kafka to your environment, right? You are going to configure your Spring Boot application to know where Kafka is. You are going to write and add some extensions to your Spring Boot applications to understand how to interact with Kafka, and then you will probably inject something, auto-wire something, and then interact with Kafka by sending messages. This is pretty much the same. In this case, the messages are going to be picked up by the orchestration engine, and the orchestration engine is going to drive that model forward. So if I make these changes here, and this is where we all need to pray, basically, all together. So I will just move to that project, demo conference C4P. Yeah, git status. Yeah, I've changed those files. Oh, they're adding CV orchestration. Git push, right? So I'm pushing that. What's going to happen, because this project was imported, a pipeline will kick in, and it will build this project, and it will release this project with these new dependencies in, with the interaction with the cluster that it's already set up and running in that environment. So at the end of this pipeline, we should all see a new project there, a new version of the project that it's going to use the orchestration in order to move the call for proposal flow forward, okay? So that's all if I didn't mess it up. So just in case, I will just run it locally just to see that the project compiles and I'm not missing anything. Yeah, it's kind of like building, so it should be okay. So we can definitely do get build logs. And I have 16 minutes. Depending on how much time the pipeline takes, we might get it in or not until the end of the demo. If not, I will explain. And you see there, like, that's the internet not answering. Let's see, again, come on. Hello, Wi-Fi, come on. Yeah, that's Wi-Fi. At least, yeah, it created a pipeline at least, and then it should show me the logs. And I think that's creating like more than just one HTTP request on the back. So that's why it might be taking more time. But as you can see on the get pods here, you will see that there is a pipeline there that it's starting. In this case, the demo conference call for paper, call for proposals service that's being built. And some interesting things in here is some Jenkins X internals, right? You can see there are 7 of 10 containers running. And you might wonder, what the hell is that? And that's basically Knative. So each of the steps in the pipeline, the ones that I've showed here, they are executed by different containers, and they are like serverless functions, right? So cloning the source code is one container that is going to have the right, Git credentials and everything set up in there to clone the source code. That will end. It will put the data somewhere, and then there will be another serverless function that is going to build the project. That's why you see all these containers being created and killed there in the terminal. And if I should be able to see there like JX build logs, it should be able to show me all the output for all these containers that are chained together. Unfortunately, no. Unfortunately, at some point, I should be able to see it. But that's kind of like the whole point. And again, when this is deployed and when it's up and running with the new version, I should be able to see here in the tool that I mentioned before that is basically a monitor for the orchestration workflows here. I should be able to see a new flow defined. And again, the whole idea of this tool and UI and the backend that it's basically Elasticsearch is to transform the data of your service. So it's the data of your service plus the orchestration data into a way that you can easily query it and get real-time information about what's going on and answer the most common, I would say, business questions of how many of these things happened in the last hour, how many of these things do I have running right now. Again, for proposals, that might not be the best thing. It might not be too difficult to implement on your own, but for more complicated use cases, this definitely is something that will help you a lot. So let's take a look again, try again. It's not there, but we can try to see if the pods are running at least. Yeah, so you can see that it's running. Something is running. At some point, I should be able to see my environment also running, saying, okay, I have a new pull request for these changes, new version of the service, and we can take a look at the repository as well. Okay, so this is my environment repository, as I mentioned before. We can take a look at here and see if something is popping up. At some point, I should be able to get a new pull request with the new version of the service here. In order to be able to apply that new version. Unfortunately, I'm not getting anything, and that's usually not good. Let me see. So my pipeline should be running there. Let's go back to the presentation to just discuss a little bit of the details of that integration. So we were here, and again, as I mentioned before, when we have the new version of this service, we will have the orchestration there. And then if we go to the front end, right, and said, okay, there is a new proposal here, the first thing that it will happen, it will say, okay, let's wait for a decision, right? And I can go to this tool to see, okay, there is an orchestration working on the decision node, which is the second node there in the graph. When I go and make the decision, so I basically send another request to the service saying, okay, the decision was made, the workflow will move forward depending on what happened on that decision. Let's say that it goes to the approved, right? It goes to the published to agenda. And at that point, then is when you should ask, okay, how is this orchestration engine is going to contact my REST service that it's running in there, right? And that's where you have different options. The first option is to create, the first option is kind of like the native option to use a pub/sub mechanism, right? It's more like message-oriented and polling kind of thing of saying, whenever I have a job that it's called published to the agenda, I will create something that will listen to that job and it will execute whatever logic do I need to execute to complete that job, right? And that's kind of like the built-in mechanism in CV that I will try to demonstrate. So you go to that service, you change it, you said, okay, now this is something that can provide, the worker for that type of job. You just change your service and you do that. But sometimes you can just not go and change your service, right? Like in this example. In that case, what you can do is you can create a worker that basically will understand how to call your HTTP services. And there are some examples out there on how to do that, and there are some generic ones that are doing most of the things that you want to do, right? If you are going for the HTTP way of calling it, then that piece of software will need to understand how to retry, for example, or how, what kind of like libraries are you going to use in order to make sure that when you're calling that service is going to be called eventually, right? So let's try again. One more thing, again, as I mentioned, we are using Elasticsearch there in the backend. So every time that something changes the state here in the diagram, every time that we move the diagram forward, all that data is going to be stored in Elasticsearch, so we can go there and query in the same way that the front end is querying and just showing some information. Let's take a look at the services. As I mentioned before, so in Jenkins X we have different environments. That means that by default, environments are created inside namespaces in Jenkins X. That's why when I do kubectl get pods into the JX staging environment, I'm getting the services that are running in my staging environment, right? And if I look at here, I can see that a new version was created, right? So a new version was created and it was started 94 seconds ago. So I can take a look now at my front end here and check at least if I have a new definition of an orchestration flow. Yeah, it was there, sorry. So it is there, right? So now this guy here says, okay, I know that now I have a service that registered a new orchestration for me to run. I will run it at some point. And we can trigger a new one by creating here a new proposal, right? Again, yep, CV proposal, right? So I create that one. Okay, that's it. Of course, that I killed the pod, that's why the old proposals went away, right? That should be solved by using a database or something like that. And if I get the decision here, I can go again here to the front end. And again, for this kind of like a scenario, having one instance, okay, yeah, it's okay. You can see it there in the diagram, it's there. But if you have 10,000 instances and then you want to filter to see which ones are there and which data do you have for that instance, you can go there and query, okay, and say, okay, this is kind of like the data for the proposal. And I don't know if you can see that, but well, that's kind of like basically the JSON payload that it's moving the workflow forward. So if I go and make a decision here, let's say that I accept it, right? So I accepted it, and I should be able to see here, where is it there? I should be able to see it here, that now it's in the publish to the agenda, right? It was accepted, so now I need to publish it to the agenda. But there is nothing waiting to execute that thing yet. So the orchestration engine doesn't know how to connect to the agenda service in order to, do whatever needs to be done in order to publish to the agenda. So let's do that change here again. And again, this is where I might run out of time, but in theory, as soon as the new version of the agenda service is created, that job will be picked up and that job will be executed. So I will just go and do the changes here in the agenda service. Here I was even more lazy, so I can just need to uncomment stuff so I can go faster. Because the changes are pretty much the same. Here you only create a worker. Sorry, no. I need to, uncomment the POM file. Right, so that's again adding the client. This is just the client side. It's not nothing else besides the client. Now I can import these things and take a look at what I'm doing. The only thing that I'm doing is that I'm registering myself. The service is registering to basically do the work that needs to happen when the agenda publish job is created. In that case, I already have the logic in order to publish a new agenda item. It was created by this method, and I can definitely reuse the same logic there, right? So I don't need to change anything. This is kind of like, it's trying to be less intrusive. You can just call any other logic that you have in your application and just wrap it up inside a worker that is going to take these kind of jobs. The only thing that I'm doing here is I'm getting the JSON information that it's been created inside the job and picking it up in order to move things forward. So I will make this change. I will check that I have that property there already. And I need to check what else is going on here. It's like an import missing. There you go. That should be it. So if I go to agenda, git status, git add, git commit, adding CV, push. Again, I will just trigger another pipeline. And again, I will have a new version of that service. And as soon as that new version of the service kicks in, it will automatically pick up the pending job that is there in that instance, and it will execute that logic, and it will move it forward. By doing this, you create like that kind of like resiliency because you don't really need to have the services up and running in order to execute that orchestration. As soon as the service is up and running, it's going to process all the jobs for that type. In this case, publish agenda publish type, right? And again, I put that type here in the orchestration model. That's the same thing that it's there. Even if you cannot see it, it's there. It's agenda publish, right? So in the same way, I created like the email worker. In this case, it's like type email. And I already did that change, and I already have my email service working with that with that worker defined. And I can show it to you here. So I have it there. And basically, this is not doing much, just calling the send email notification logic that I already had before, which is in this case just printing it out to the terminal. Super simple integration, not real life, but it's just trying to make that point. And we can test that worker already by just going and creating another one here. Reject, yeah. Reject me, please, right? So I can create that one. It's there. Instead of accepting it, I will reject it. That means that the flow will go through this path here, and because the worker is already up and running, it will just basically complete the orchestration in that case. So if I reject it, it should go there, and at some point come back and said, okay, it's done. Yeah, so you can see it there, right? And it's green, but it should be gray because it's done. Yeah, let me mark the completed instances. It was fresh, that's why. So yeah, it's done, right? So for that path, it's already working because all the workers are there. For this path, it's already waiting for the new version of the agenda service to be deployed in order to process that job, right? Again, you have that option of using pub/sub with the like normal worker mechanisms. If not, you have some generic workers that can call HTTP services for you if you want to do that. Of course, you can create any kind of integration there by using Spring or using any other framework like Camel, for example, where you can say something like, just send a Kafka message every time that we have that. And then you will have something else that will pick up that Kafka message and do that for you. There are some examples using Kafka as well. When you think about this for like very high frequency, low latency kind of scenarios, using Kafka and these kind of tools makes a lot of sense. Again, the most common question sometimes that I get around these technologies is like, well, this is pretty much like a pipeline, or it's a workflow, or it's something that you can do with something like Camel as well. But this is usually targeting some other use cases where it's more like high level and more business oriented, right? In this case, this graph is basically allowing you to share with other people where the proposal is in general. It's more business oriented. It gives you more high level overview about what's going on. 3 minutes. So it might be that the service puts up and that's completed. If not, that's what will happen. I can guarantee you that. The source code for this example is open there, and it's free if you want to run it. I totally recommend to try Jenkins-X, as I mentioned last year. I'm running it in Google. If you go to Google Cloud, you have $300 free trial where you can definitely run this example and a bunch of other things for a month. So there is kind of like no excuse not to try this out. And also just import your projects and see how it works. Let me go to the final slide, I think. It's pretty much the final slide. I cannot promise you coffee, but coffee is out there. But the main takeaways from this session are like, most of the things that I've showed, they are like based and created as like open source projects. So you can join them and you can learn a lot of things from those. I've learned a lot of things from Jenkins-X on how to design for Kubernetes. That's there, it's open for you to take a look and see how it works and just use it. Contribute back to the community if you want. If you don't, that's fine. But at least you will get a lot of experience on how people is building super, super complex software on top of these platforms. In my experience during the last year, 2 years, basically, I've seen a lot of wasted time into deciding what to build and what to integrate in this, Kubernetes ecosystem. And the only way to speed up those decisions, it's basically creating a framework for your team and for your company into basically saying, okay, what's going on in the Kubernetes community? Who is solving which problem? Should we solve that, or is that's not part of our core business? If it's not part of our core business, we will just go and integrate with something. And again, that basically takes you to focus on business value. If you think that you're spending too much time on pipelines, well, that's why Jenkins-X is trying to, bring all this experience from the Kubernetes community into the project. The same with CV. If you want to do this and you want to do it like high frequency, low latency, building that on your own, it will take you so much time that it doesn't make any sense. So just integrate with something. If you have questions, again, Slido, I'm pretty sure that you have that kind of questions, or even that kind of questions, or even bigger questions. And if you have bigger questions, and Slido is not the best place to ask those, please reach out. I will be here today and tomorrow. And in the last 41 seconds, I just want to see if the service is up, and I will have a perfect demo, which is very difficult to believe. Nah, it's not running there yet. And let me see if I can do build logs. That's definitely not working for some weird reason. 18 seconds, so it's not working. I would just keep checking. 8 seconds. Wait. 8 seconds. So 11 seconds. 9, 8, 9, 7. That's going to take at least 30 seconds, so it's not going to be ready in time. I might be able to be like 15 seconds late, but let me see. So if it's running, I will just leave it there. Yeah, it's running now, so that means that it's going to start. And now if I click there, they are both completed. I did it. Thank you very much, guys. That's awesome.